Okay, so you basically had three methods, right, for preparing salts, and this is the third one, which is titration. So I'll just briefly go over the first few, which you've already done. There was an excess method. When do you use excess method? You use it when you have an insoluble reactant and you're making a soluble salt from it. So you've got an insoluble reactant and you're trying to make a soluble salt from that reactant. Then you've got the second one was ionic precipitation. So ionic precipitation is ionic precipitation was used, or simple precipitation, that is used when you have to make an insoluble salt from soluble reactants. So you got a soluble reactant and you're trying to make an insoluble salt out of it. And the third one is titration. Titration is going to be used when everything is kind of soluble. So that's when you use titration. So you've got your reactants are soluble. So you've got soluble reactants, and at the same time, you're trying to make a soluble salt out of them. So that's when you use titration. So first thing, it all depends on the solubility of the substances. So you can, I mean, this over here shows the solubility of different compounds. I'm just going to copy paste this one onto the board. So just a second. No idea where it went. Just a second. I should say. So this thing, you need to know the solubility of different compounds. So you have to know that which compounds are soluble, which ones are insoluble. I'm going to share the sheet as well. The sheet over here has everything that you need to remember. It's a 2-page sheet where it's everything that you have to remember to pass a chemistry exam. So, I mean, it's got the ions and the name and the charges. It's got the acid names, etc. So pretty much all the information, the relevant information, it's given over here. And you've got 4 or 5 reactions where you make salts. Basically, there are 4 of them. So I'm going to copy those 4 reactions. So you've got these 4 reactions which are used to make salts. So these 4, it's an acid-base reaction that produces salt and water. You've got an acid plus metal carbonate reaction that produces salt, water, and carbon dioxide, and so on. Acid plus ammonia produces ammonium salt. So you've got these 4 reactions that are used to make salts. So remember, titration is when the reactant, it doesn't matter which reaction it is, as long as the reactants are soluble and the salt that you're trying to make is also soluble. Just for the sake of reference, I'm going to copy the acid names and their formulas as well. So to make any salt, you need an acid. So an acid gets neutralized, and that results in the formation of a salt. So let's say I'm trying to make a salt, and let's come up with some equations. So for example, I'm trying to make magnesium chloride. Now magnesium chloride is Mg is 2+, Cl over here is -1. So the formula of the salt is going to be, if you do crisscross, it's going to be MgCl. It's going to be MgCl2. So I want to make this salt. What reaction could I mean, which reactions could I use to make MgCl2? So I could either have an acid plus base reaction and produce a salt and water. So, or it could be an acid plus metal carbonate. So can anyone tell me, to make this salt, which acid should I use? I mean, I've got lots of,
HCl.
it's going to be HCl because it's got a chloride, it's got Cl in it. So it's probably the acid that's going to be used is going to be HCl. And you've got 3-4 options. You can either use a metal. So the metal in this case would be Mg, and it's going to produce MgCl2 plus metal plus acid produces H2 gas. The other option that we can have is a base. So I'll just copy the same thing. So the other option for making the same salt is, the acid is going to be the same. I could use a base. What's a base? A base is a metal oxide or a metal hydroxide. So let's make that MgO. So that could also be used. In that case, a water molecule is going to be produced. Or I can have another reaction where I'll have, so just hold on 1 minute for the azan. Just 1 minute. As I said, let's continue. So I told you that to make any random salt, you've got 4 reactions. The fourth one usually doesn't count because that's for an ammonium salt that has NH4 plus 1 in it. Anyway, so I came up with this salt that I wanted to make MgCl2, and I had 3 reactions. I could either react a metal with an acid, a base, which is a metal oxide or metal hydroxide. With an acid, it would give you salt and water, or I could have a carbonate reacting with an acid and it would produce the salt, water, and carbon dioxide. These are not balanced equations, so I think it's probably going to be 2 over here, 2 over here as well. Now it's balanced. But anyways, the problem is we were going to discuss the titration method, which is going to be used when the salt is soluble, the reactants are soluble, and the salt is also soluble. But in this case, in the first equation, Mg is a metal, it's a solid. So that is definitely not soluble. So you can't use titration in the first one. In the second one, again, you can't use titration because magnesium oxides are insoluble. How did I know that magnesium oxides are insoluble? Because it's written over here that oxides and hydroxides only of group 1 and NH4 plus 1 are soluble. And some of those that are lower down in group 2. So magnesium is definitely not there. So it's either group 1, like the leftmost in the periodic table, that's their oxides, hydroxides are soluble, and the ones at the bottom of group 2. So, and carbonates, what is written about carbonates? For carbonate, it says that all carbonates and phosphates are insoluble. So except group 1. So this is not group 1. So it's not an exception. So all carbonates are insoluble. So this one is also insoluble. So which is why that's a solid. So the thing is, based on the solubility, based on the states, you can't use titration in this case. So titration would only be used when all of them are soluble. So let's try this with another salt. Let's say we have, I'm going to make K2SO4. So if I want to make K2SO4, which is, now K is group 1. According to the table, group 1, everything belonging to group 1 is soluble. So potassium sulfate is aqueous. And again, you've got 3 methods. You've got, what acid would I use to make this salt?
H2SO4.
Okay, so it's going to be H2SO4 because it's got SO4 in it. And I've got 3 options now. It's either going to be potassium metal, which is going to be used. That would produce metal plus acid produces salt plus H2. So I will have, to make this salt, I can have 3 reactions. And let me add all those 3 reactions. So it's either the first one, it's metal plus acid, it's going to produce H2 gas. And you can balance this. The second one, you can have a base, which is metal hydroxide, and that would produce a water molecule next to it. Or the third one, you could have a carbonate. So it's going to be K2CO3 because CO3 is -2 and K is +1. So if you do crisscross, it's going to produce salt, water, and carbon dioxide. So now the question is, you've got 3 options, 3 reactions that you could do. The first one, you can't do the first one because remember, there's a limitation to metals. You can't do the first one. The reason is this reaction over here, the one that involves a metal, not all metals are capable of reacting with properly. The problem with metals is that some of them are very reactive and some of them are very unreactive. I mean, like, you can't make a gold salt by using gold because gold is extremely unreactive. So you can't do that in the lab. So for metals, remember, this reaction with metals would only produce a salt with these metals. Just remember the word mazet. It's magnesium, aluminium, zinc, iron, and tin. Let me write M properly. So it's mazet. So remember, this particular reaction will only work for salts that involve magnesium, aluminium, zinc, iron, and tin. Any other metal would either be too unreactive, so it's going to take a very long time, probably years, for the salt to form, or it might be too reactive. in this case, potassium can't be used because potassium is group 1 and it is extremely reactive. So that's going to result in an explosive reaction. Okay, so potassium is even more reactive than sodium. You must have seen some videos of sodium being very explosive. So you can't really make a salt using this. It's going to be highly unsafe. So it's going to be a terrible way of making a salt. So remember this metal plus acid equation can only be used if the metal is part of the Mazet metals. But the other two are fine. You've got potassium hydroxide, you've got potassium carbonate. So there's nothing wrong with them, but the metal can't be used. Anyways, group 1, anything that belongs to group 1 according to the table, that's aqueous. I mean, it's written over here. If you look at the solubility table, it's written over here that all nitrates, anything that has NO3 minus 1 in it, anything that has group 1 in it, anything that has NH4 plus 1 in it, all the compounds are going to be soluble. So potassium hydroxide is soluble, H2SO4 is, all acids are by default soluble, K2SO4 is already aqueous, and H2O is a liquid. You don't write aqueous with H2O because it won't make sense, H2O being dissolved in H2O, so you just write liquid to it. Similarly, potassium carbonate, anything that belongs to group 1 that is soluble, H2SO4, that is soluble as well. Water is a liquid and CO2 is a gas. So both of them, you can use titration. There's nothing wrong with using titration over here because it fulfills the primary condition, which is that the salt is going to be soluble and the reactants that you're going to use to make that salt are also going to be soluble. So for both of these reactions, you can do this reaction using the titration method. Okay, so is this clear? First thing, when to use titration? Clear है सारों को?
Sir, I have a question.
Yes.
Sir, we can use any soluble potassium salt, right? So potassium nitrate would also work?
नहीं, potassium nitrate for titration, right?
Yeah.
Yes, it can work. It's not the salt that's going to work, okay? Remember, as long as the condition is fulfilled, like let me do this for potassium nitrate, the same thing. Let's say I'm going to try and make potassium nitrate. So if I try to make potassium nitrate, पहले तो बताओ कि what acid would I use?
Sir, I meant potassium nitrate in the reactant as a source for potassium.
No, it can't be potassium nitrate because potassium nitrate does not have a reaction. The only reactions that happen are it's either a carbonate, metal carbonate reacting with an acid that's going to produce salt and water. A base is a metal oxide or a hydroxide that would react with an acid, produce salt and water. Or it could be a metal reacting with an acid. I mean, there's no reaction for a nitrate, so it can't be your reactant. Is that clear?
Yes, sir.
Okay, so you've got only these four options: base, metal oxide, metal hydroxide; a carbonate, metal carbonate, or simply a metal. The last one is for ammonium salt, so you can ignore that for now. Okay, so you've got just three options. So it can't be a sulfate, it can't be a nitrate, it can't be. I mean, the reactant could not. It has to be either a hydroxide or an oxide or a carbonate. I said, anyways, so let's pick one reaction and let's try and figure out what is the excess method. Sorry, not the excess method. What is titration? So let's pick this one, and we're going to discuss titration now. Now, the first thing is, what's the problem of doing this reaction in the lab? Remember, titration is the practical method, how you're going to perform this reaction. So here's your beaker, and now the easy way is there might be a bottle labeled H2SO4 in the lab, there might be a bottle labeled KOH, right? You just mix them together, that's it, you'll get a reaction. So here's this tiny beaker, here's another tiny beaker. This one contains H2SO4, And this beaker over here contains KOH, right? So what do? You just mix them together. You grab two bottles and you mix them together. And there's going to be a reaction, and K2SO4 plus water are going to be produced, right? So, but there's a lot of problems with this. Like, why can't you do this? So why can't you just pick KOH and you pick H2SO4 and you mix them together? What could go wrong? Can anyone tell me what why can't you do this? Does anyone have any idea? Any random answer, just make a guess.
Sir, they're all soluble.
Okay, they're all soluble. And the problem is, okay, by just looking at the beaker, if you look at a glass of water, you can't really tell how much sugar or how much salt is dissolved in it, right? So if you go into the lab and you grab this piece of this beaker containing KOH, you have, because you can't see the KOH, you don't know how many particles are dissolved in it. So let's say there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 KOH particles dissolved in it, right? But you can't see it. You don't know, like by just looking at it, you can't really, it's a colorless solution, you can't really tell. Or दूसरी side पे you've got H2SO4 and they're just 3, 4 particles dissolved in it, right? So if I mix them together, so KOH would be added in excess. वो बच जाएगा. There's going to be some unreacted KOH left because you're adding too much of it, right? So your salt is going to be formed, but the salt would be contaminated by the extra KOH that you're adding. Right? Because by just looking at the beaker, you can't really tell how many particles are dissolved in it, right? And by looking at H2SO4, you can't really tell how many particles are dissolved in it because it's a colorless solution. So if you just grab them and you mix them together, so one out of the two, one of the ingredient out of the two would be added in excess, and your salt is going to be contaminated by it. And since the ingredients that you're using, they're both soluble, you can't filter them out. क्योंकि KOH को बाहर नहीं निकाल सकते, वो एक दफा अंदर चला गया, बीच में mix हो गया. The KOH is soluble, so you can't just filter it out. It's going to be impossible to separate it, right? So is this point clear why this method will not work? Because the salt is going to be contaminated. Y clear es algo, Saim, Turhan, Bayim, Basim, is this clear? Is this thing clear?
Yes, sir.
So now what you have to do is, this is what you have to do. You have to somehow ensure that if you're adding, I said there's a problem over here that this is, it's not a balanced equation. I said now the problem over here is that both reactants, they must be added in exactly the same ratio. Like there should not be anything that's in excess. You should not add excess. This is what you have to prevent. So how can you figure out, because you can't limit, remember you've got a colorless solution in a bottle and you can't count the particles. So you have no idea how many particles there are. यहाँ पे तो मैंने draw किया हुआ है, लेकिन otherwise you're just going to see a colorless solution. So the challenge is you have to add them in exactly the same amount so that nothing is left at the end of the reaction. The only product that you're going to get is your salt and water. There's no extra KOH added. There's no extra H2SO4 added. All that you add, it completely reacts. The ratio in the equation is 2:1. So if you add 10 particles of KOH, there should be 5 particles of H2SO4 added. If there are 100 particles of KOH added, there should be 50 particles of H2SO4 added according to the ratio. This is like a recipe. The recipe says that if you add 2, so you should mix 1 of H2SO4 into it. So, so nothing extra should be added. Now that's a problem and that's a challenge because you can't count the particles in the first place and you can't see them in the first place. So which is why you do titration. Now titration is kind of, titration is like this. Titration involves a burette. So burette is a long, thin cylindrical device which has graduations on it, so you can measure any volume on a burette. Just a second, let me. So you can measure any volume on a burette, and it's got a tap at the bottom. So this is I mean, you can Google. I'll Google burette at the end, and there's a conical flask at the bottom. Let me just draw. One second. So we've just 1 second. ठीक है, so इससे गुजारा कर लो. So we've got a conical flask at the bottom. And so that's it. So that's a conical flask. Anyways, you've got these two reactants, and you've got to mix these two reactants together. So you've got QH and you've got H2SO4. So what you're going to do is you're going to pour H2SO4 or QH or any one of the reactants, any one of them. We can add it in the bottom flask, conical flask, and we'll fill the burette with H2SO4. So the burette is going to be filled with H2SO4. There's going to be a certain amount of KOH which you can't count. I mean, because you can't see them. You can't. I mean, just like adding salt to water, I mean, you can't count the salt particles in water. So let's assume there's some amount of KOH that's added into the flask. अब आप क्या करोगे? You'll start opening the tap and you'll start pouring the H2SO4 into it. As soon as you start doing that, the H2SO4 particles from the top will react with the KOH particles, and the KOH will start to slowly turn into salt. One by one. So one by one, the KOH will start to turn into K2SO4, the salt plus water molecules. Because this is what happens. I mean, the reaction states that as soon as you mix KOH with H2SO4, a salt and water molecules are going to be produced, right? So this is going to happen. So one by one, all the QH starts getting used up because it reacts with the H2SO4 that's falling from the top, and it reacts with it. So the KOH slowly starts to turn into K2SO4, and one by one, the KOH quantity decreases. The reactants, they get used up. So is this clear up till this point? You clear? Is this clear? Mayim, is this clear? Basim?
Yes, sir.
Achha, so the task is, so imagine you're slowly adding H2SO4 and it reacts with KOH and it produces the salt and water molecules. There would come a point when you add a few drops of H2SO4 and the last particles of KOH, they also react. And now all the KOH is gone. And this is the point where you should stop the tap, turn off the tap. So this is the point where you should actually stop, because KOH is completely gone. It's completely gone. It has reacted with the H2SO4 falling from the top, and it's formed the salt and water molecule. So there's no more KOH left. So what if you don't stop at this point? If you don't stop at this point, there's going to be further KOH H2SO4, it's going to continue to pour into it, and the reaction, there's not going to be any reaction because there's no KOH left. So now you're going to have excess H2SO4 क्योंकि आपको बंद कर देना चाहिए था, but you have not stopped the tap. So now there's extra QH that's extra, sorry, H2SO4 that's falling into it. So पहले the flask contained QH. Slowly, one by one, as the H2SO4 fell into it, the QH turned into salt and water. And once all the QH was gone, you should have stopped the H2SO4 falling into it. But if you didn't, there's going to be excess of H2SO4 that's going to be added to the flask. So this is what's going to happen. So the point at which you should stop is before you start adding the extra H2SO4. This point pe na KOH khatam ho gaya na, at that point you should stop. So how would you know, or how would you figure out when to stop? Like, because visually speaking, as an observer, you won't see anything. You'll just see a color solution pouring into a color solution. You won't see this happening. I mean, so if you're just standing there, you wouldn't know, has the point been reached or not? I mean, by just looking at it. So how do you figure out, how do you get the cue to stop? The way you figure that out is that initially the solution was basic because it had KOH in it. Then at a certain point, all the QH got neutralized, it reacted, and it ended up producing salt. So the solution became neutral because it's got salt in it. But if you did not stop the tap and you continue to pour in H2SO4 into the flask, the solution would eventually turn acidic because there's going to be extra H2SO4 added to it. So the cue that you're going to get is by just looking at the pH. Basic means if the solution is basic, that means there's still QH left in the flask. If the solution is acidic, that indicates you've added too much of H2SO4 into the flask. If the solution is neutral, that means you've stopped at exactly the right time. And this is what you want. You want to stop at this point. Is this clear as well, this thing?
Yes, sir.
So you need something that could measure the pH. You need something, because you need some indication, because right now it's just a colorless solution falling into another colorless solution, so you can't see anything. So you need some visual observation that can tell you whether the solution is basic or it's acidic or it's neutral. So the way that is done is by adding a few drops of indicator to it. There are two popular indicators that are used. One of them is just like a litmus paper. There's one which is methyl orange. And there's another one which is phenolphthalein. So these two are frequently used. And they have some color changes, like the solution at the top. If it's alkaline, methyl orange is going to have yellow color. So the solution is going to appear. And so if this is alkaline, methyl orange is going to give you a yellow color. Vice versa, if this is acidic, it's going to turn red in color. So I'll show you the colors of methyl orange in acidic and basic medium. So maybe there's hopefully there is some, यहाँ पे दिया वैसे हाँ ये ठीक है. So this is how your solutions would change color, and that would be your visual cue. कि कब अपने tap off करना है, ठीक है? That's going to tell you exactly when to turn off the tap. The other one is going to be phenolphthalein. That's also an indicator that changes color. So phenolphthalein would look like this. It's got two colors. I mean, one of them is colorless, the other one is pink. In alkali, in basic conditions, it's pink or purple, light purple. And in acidic conditions, it's colorless. So I'm going to write down the color changes for methyl orange. So this one is going to be red or orange red or reddish orange. And the other color it has is yellow. And this one is going to be colorless in acetic. And the other color is going to be pink. So in acidic medium, so this is acidic, this is basic. So you need to remember these color changes. So if this solution had methyl orange in it, initially it would be yellow. So in basic medium, it's going to be yellow in color. So it's going to be yellow if it had methyl orange added to it. And if the solution had turned acidic, then it would have turned red or orange red. So that would indicate that you should immediately stop. Okay, you're adding H2SO4 from the top. Initially, it has KOH in it. The KOH starts to react. The solution is yellow at the moment because methyl orange will give a yellow color in basic conditions. At a certain point, all the KOH is going to react and the solution would become neutral. So if by adding a very tiny drop of H2SO4 and you add in excess of H2SO4, you should have stopped. If you add a few drops of extra H2SO4, the solution would start turning acidic. And if it turns acidic, it would immediately go red. That would indicate that bhai, aap ab zyada H2SO4 dal rahe ho, you should stop immediately, turn off the tap immediately. So this is how you're going to do. It stays yellow, yellow, yellow. And as soon as it turns red, you immediately stop. Is this clear, this thing?
Yes, sir.
Clear?
Yes, sir.
ठीक है. चलिए, so every time remember, तो मैं इसको sum up कर देता हूँ. Every time what you have to do is, okay, when everything is soluble, ठीक है, remember, when you're making a salt, the reaction could be any reaction as long as the reactants are soluble and the salt is also soluble. Then you would have to use titration because first thing, you can't just randomly mix two solutions. If you add too much of one of the solutions, then it would be impossible for you to take it out or filter it out. So your salt would be contaminated by the solution that you add in excess. So the whole task is, okay, don't add anything in excess more than the required amount. So which is why you do this. You drop by drop add H2SO4 to KOH. You make KOH react and turn it into a salt and water. As soon as it reacts, you're going to stop the tap and your task is not to add extra H2SO4 because at the end of the day, you just want the salt and water molecules. And the visual indication would be given by the indicators that you've added because they're going to change color based on the pH. It's basic initially because it's a metal hydroxide. It turns acidic because it's when you add excess H2SO4. This is what you're going to stop. It turns yellow, yellow. As soon as by adding just a single tiny drop, if it turns red, stop immediately. That means you're going into this territory. You're adding too much of H2SO4, and that is what you're not supposed to do. And that's about it. So at the end of the day, you'll get salt and water, which is probably not going to be contaminated by anything. This kind of method, we'll discuss the method. We've gone over the method. What we'll discuss in the next class is how are you going to explain this in the exam. Okay. So we'll do that tomorrow then. Clear?
Yes, sir.
तो ठीक है, कल फिर ना कंटिन्यू करते हैं. चले, ओके, टेक केयर, अल्लाह हाफिज.